Hello everyone and welcome to the course. We can start directly. So we are discussing the week 3 discussions. Let's go with the slide then. So hopefully my screen is visible, and so I am Udiptya, for those who are attending it for first time, from IIT Madras, and this is the week 3 discussion. And so most parts of this week 3 was focusing on developments of science and the influence of philosophy. So it was kind of a timeline that discussed the how the root of science took, and what were the different schools of thinking that essentially helped it develop or give it a root to the modern thinking of science that we essentially see today. So first was kind of the emergence of materialism and idealism. So we see different kinds of thoughts, two schools of thought, essentially the primitive materialism and then the onset of idealism. So essentially we have talked both of this separately in the first weeks, and these are only the thoughts and how the thoughts have emerged. Then we see something about the Renaissance period, and the impact, and during then the scientific achievements that happened during that time that helped us with the scientific method, and how Newton was one of the important figures in that period, and how he went with got some scientific essential scientific achievements, and that led others to also develop during this period. Then we come to the period of empiricism, and then so that had also a kind of empiricism, and then mature idealism, positivism, and then we got something to evolution and revolution in science. So we saw that how science is something that evolutes, and how it revolves with other areas of science also. So that also we see. In the last video, we see the importance of science and the importance of India to the modern scientific world. So so the first, as I discussed, the journey from materialism to idealism. So we see something. First, it developed from the primitive materialism. So basically, in the early period of human society, like during the ages of times of hunting and gathering, whatever substances they saw, the people saw, it was all the thinkings were based on those. Like they saw the stones, hills, the rocks, the moon, and then all of their scientific thoughts were basically revolving around those items only. So that is essentially called as the primitive materialism period. Then we got down to the idealism period. So during that, and also this primitive materialism. So in this period, primitive materialism, they also so during this time they also developed something very important, that is agriculture. So agriculture was something that developed during this period. So one of the important remark or important milestones in the human even development was happening in agriculture. That essentially led to the settlement of societies and the bringing up of societies and human societies and human civilizations. Agriculture was one of the important parts of it, and also slavery was also an important part, because as agriculture and such things developed, people needed somebody to work for them. So that's how slavery also developed. Then also we got down to idealism, when it was the period when the different thinkers, basically it was the period of thinkers where, where different philosophers gave their ideas, and thus it formed as a scientific argument. So we had people like Plato and Aristotle. So those were one of the cornerstones of this period, Aristotle. And then we have Ptolemy, and also Pythagoras was somebody who was a prominent figure in this period. So such personalities developed in this, and they had their own thoughts and ideas. Those were essentially based on idealisms, and nobody questioned basically them. Then the time of then during the Renaissance period. So this is the Renaissance period around 15th century. Something called a scientific method was developed, which had cornerstones of these people. So these people were essentially important figures in this time. So Galileo Galilei basically was somebody who had developed telescope at that time. So he was a big person, and that time he was also somebody. So during that time, the Copernican theory of solar system was also developing, and then Galileo was somebody that contributed to the telescope. Essentially, helped us see the outer system other than Earth, and also see the uh, how the planets look, how the planets spotted, and how the sun looked, and all these things. Uh, so yeah, so basically this time it was kind of thus the transition period, and people were not essentially ready. Their philosophical view was mostly on the idealistic people, where those big peoples where they essentially made the schools of thought. So essentially so people coming and rejecting their ideas, or something not that was not looked upon that time. And essentially the church, which was the essentially the authority, was something that had the doctrine, or whatever the church believed was something that has to be believed by the common people, and going against it is something that is kind of considered as a crime. So around that time, several scientists also were kind of executed due to this going beyond, or going uh, against the church doctrine. So then came the scientific method, and Galileo Galilei basically emphasized that. Uh, so he emphasized that every the thing of quantification. So he emphasized that quantification is one of the important uh, one of the important pillars of scientific method. So everything needs to be quantified, and essentially that's how we will get a better understanding and scientific overview of a system. Then came Francis Bacon, who gave the idea uh, of experiment, then observation, and then inference. So he told that how experiment needs to be designed, and how it is not a personal view, and it should be a collective experience, and from that experience we need to build our inferences. And that's how he developed this method, and he also followed the laws of inductive logic that we saw last time. Then comes the Descartes. So he essentially was somebody who essentially applied different. He was of the philosophy of using breaking down every system into premises, and that's what we looked in the last thing, and to use it for deductive logic. So he was also somebody who was a great mathematician, so he also wanted everything to be quantified, and uh, so he and apply and to be mathematically logical. So something was mathematically to be mathematically logical or presentable. So that's how he developed the Cartesian system. So where everything can be plotted and quantified, and it can be showed uh, visually. Cartesian system. So these three persons were one of the pillars at that time. Then we come to the Newton's contribution. So during this time, so this period was around the 1650 AD to 700 AD. So we see some important developments during this period, it's like different societies of science, then important laws coming out, like gas law, Robert Boyle's gas law, and then Hooke's law of elasticity, and several invention of microscope. Several of those carried out. So, but one of the important contribution that came out was Newton's law of equation, Newton's three laws of equations and law of universal gravitation. That essentially made a quite difference, because that essentially penetrated the people's minds, and the importance of it was that these laws essentially can predict of a system's future state. So essentially something that gave a simulation kind of behavior. So whatever we essentially knew everything, we could get extract the information without essentially doing the or practically doing the system, but actually theoretically can derive a lot of information about that future state. So that essentially helped in development of the mechanical materialistic view. Materialistic school of thinking, in which everything so essentially everything has a fixed laws, and so everything move in a mechanical state, there should be some kind of flow, and there should be some kind of fixed laws that essentially derives and essentially rules everything. So fixed laws were something that was derived here. Then the journey ahead was on the empiricism period, in which we see how the importance of experience. So as a source of ideas, and so it was the source of ideas and knowledge. So people believed so whatever they observed or experienced, that was kind of the science revolved around it. Then we had the period of mature idealism, in which so people essentially saw, so there was two kinds of schools here, which so in this period the so ideas were given the prominence here. So, and then there were different kind of ideas like Pele's William Pele statement, William Pele statement on uh, uh, God, God's intelligent design. So, so essentially, such ideas, such materialism was something that essentially stopped a lot of things. Like then people were so one of the important thing was the area of the classification of animals, or the uh, classification of the biological world, to be precise. So those things people didn't so and the idea of evolution. So because they told that so there was, if God's intelligent design, there was something called as God intelligent design, then there was no sequential or the with time the idea of natural selection. So these ideas were something that defied the areas of natural selections. Then we got to some, so basically then the period of Charles Darwin, and they developed how the living organisms developed, and then the cell theory that was also derived at that time. Then we had the period of scientific materialism. Uh, so it was around the 19th century. So yeah, so there we understand that everything uh, everything was not something like how. So here we felt the ideas that the mechanical materialism gave failed in some sense, because they couldn't explain. There was now such fixed laws that can essentially explain everything, and there was some changes that essentially had to be made. So we will see that so what were the some of the failed points that the mechanical materialism saw. And then then there was the idea of positivism that was there for a short bit of time, and then so essentially that advocated the idea of whatever we observe, uh, we need to work on that. Something that is not observable was essentially not kind of scientifically to be proven. So that was what positivism was. Then after all these theories, we understood that the importance of evolution and revolution of science. So uh, essentially we saw that so one of the important point here was science is cumulative. So there is no such fixed laws, or how important this contribution of each scientific endeavor, and how that essentially makes up a bigger, broader science. So that essentially made that told that science is cumulative. And then the importance of revolutionary science. So revolutionary science was something that essentially, so we saw during the ideas that how the different like the Newton's inventions, Newton's laws, and then before that the ideas of different scientific areas, scientific schools of thought essentially gave us the different shifts in the area of science. So essentially the paradigm shifts, these we call as paradigm shifts. So essentially they make the difference in the science, or breakthroughs in science, and that's how we get a different thoughts and to go ahead with science. So revolutionary science is also an important part of it. That's what was the uh, essentially the broad view of how science developed and how the thoughts on science developed. So essentially, it is kind of a philosophical thing that we are essentially handling this time. So first two videos were most on the theoretical part on what the different terms here that we discuss essentially dealt with, and this is kind of a timeline that we are following. So now the problem discussions. So you all can write on the chat, and then we can also discuss and go with the questions. So this is the first problem, and this is a single correct one, and there are different options, and you can write the options in the chat box, whatever you feel would be correct. So the Greek philosopher Empedocles believed that everything in the world is made of four elements: air, water, earth, and fire. This is an example.
Subjective materialism.
Okay. So we have learned about the different terms here that was discussed: subjective, objective, and idealism and materialism. Can somebody summarize the terms? Like what is subjective? So
Yeah,
subjective. Yeah, please.
so first of all, like materialist is because like they are giving materialistic thing priority. Okay, so like all the elements, air, water, which we can see, which we can at least feel or touch. Okay, so those were the inspiration. So that is like the inspiration was coming from a particular matter. That is why materialism. And subjective, it's because the thought was, everyone can have his own thought. Okay, so someone would idealize like water is the most important element, so that is why water is everything from where everything is built. Someone would say that no, earth is the most important element, and that is why like everything is built from the earth. So every idea was coming from a particular kind of matter, but it was subjective to everyone's subject, like whatever you think, whatever you do. So that is why the answer could be subjective matter.
Okay. Anybody would like to add anything?
Edipka, can you explain between all of them?
Please, I couldn't hear it. Please, can you repeat?
Yeah. I said, can you explain difference between all of them?
Okay, yeah. One of the so yeah. Essentially, I was asking if anybody could explain what is subjective, objective, and then we have idealism here, and materialism. So these are the four terms that we are discussing. So can anybody explain subjective, objective, any difference between subjective and objective?
Subjective is mostly based on whatever we see, feel, and all. And objective is based on the data, like experiments. So that is what I understand it. I don't know whether I said it.
Okay. Anybody else would like to add anything?
Subjective is related to the different view of having different thoughts. That's why it is subjective.
Okay.
And then the materialism that consists of the air, water, earth, and components. So even philosophers they thought the air CPM matter, quantum matter, what
Hmm.
the Barton matter. So everybody was having their own perspective on this matter. Divide this.
Okay, yeah, yeah. So basically, the subjective thought is something that is dependent on the personal realization of the subject. The subject here is the person or the observer, essentially. So it's the
Sir, can
observer's.
we, sir,
Tell,
excuse me, can we
please,
say
please.
random is perception can be changed as a two person given to different statement, and the objective is the rising science follows it.
I didn't understand actually. Random. What you told?
Sir, objective
Hmm.
science follow it. Objective.
Yeah, yeah, yeah. Science, like modern science, follows objective kind of thinking. Subjective think. So essentially, we are essentially this topic sees the timeline about how science developed. So this is the example when like at a time there was a time when science followed subjective thinking. So yeah. So and the difference between idealism and materialism.
So in materialism, we believe that everything is made up of matter,
Hmm.
and there is no supramatter kind of thing. So when
Okay.
it comes to supramatter, it could be like thoughts like ghosts or something like an invisible power.
Hmm.
Okay. So in materialism, like everything is believed to be coming out from matter,
Hmm.
although there could be a limit in our knowledge, but like the concrete idea is everything has to be coming from a matter. Okay, so matter
Okay.
is given priority in materialism,
Hmm.
and in the idealism, the idea is given the priority.
Right. So
So
yeah.
yeah.
Yeah, to summarize, maybe materialism is something that give
Independent of
matters. Please, yeah.
it is independent of matter.
Okay.
Matter.
Yeah. Uh, yeah. So actually, the yeah. So essentially, the materialism says that matter is the primary thing, and the idea is a secondary. So those ideas that are created are essentially because of the matter. But whether like in the reverse, the idealism people says that there is no existence of matter, and essentially we see that matter because essentially we have generated the idea about it. So that's how the areas of idealism and materialism is developed. So here
Idealism, sir,
please.
idealism, what is idea or what is in our mind tells, what our
Mhm.
mind tells.
So
And
it's
in
like
materialism, to seek
mm,
the
oh, okay.
instant gratification of our desires.
Mm, yeah, got it. Yeah. So yeah, so as one of you explained, the answer here will be the subjective materialism because here the Greek philosopher is a subject here, and who observes or believes that essentially these are made of these four elements. So here the four elements is something that is a matter, and as he's giving prominence to the matter here, we can think this school of thinking as the subjective materialism. Okay. So if anybody has any discussion on it, also we can go to the next. Okay. So as we discussed, Francis Bacon was somebody that had important contributions in the Renaissance period for the development of scientific method. So here, like is a short question on how important, what was the important thing that he introduced.
B and C.
Okay.
Of logic, observation and collection of data.
Okay. As I mentioned, this is a multiple correct.
B is the answer, sir.
Okay. So multiple answers can be correct essentially. So, as one of you mentioned, the Baconian approach essentially revolved around. So, one of the important parts of Baconian approach was that to obtain. So basically, he has important emphasis on direct observation, and essentially the collection of facts, and then essentially use and then to obtain the truth from the facts. So he used to develop this high amounts of direct. So he used to perform this collection of huge experiments and essentially make truth from the facts, which we essentially saw in the time of inductive logic, where we essentially got we used to get some we used to develop thoughts depending on some known facts. So that was something that was followed during those times. So essentially here the observation and collection of data and application of inductive logic was something that was important. So application of mathematics was something that was greatly emphasized by can anybody tell? So Rene Descartes.
Gerard Descartes emphasized.
So he was kind of very firm advocate of application of maths. So moving ahead, so Pythagoras was another thinker during the eras of onset of idealism, and that's how they developed. They told that. There are some ideal symmetric figure. Okay.
Is it a multiple choice, is it?
It's a single correct option.
Yes.
But essentially, he had mentioned two ideal geometric figures. One of them is
Hmm.
in the is in the options, and one of them is not.
A is the correct answer.
Okay. So essentially, yeah, it's C actually. So it is kind of a diversion. So yeah, he developed Pythagoras theorem that essentially uh, told the importance of opened a lot of things in the right angle triangle, but he believed that the circle was the perfect was one of the important was one of the ideal geometric figures. Another one is so so basically he was telling the 3D so circle being the 2D structures, and in 3D the sphere. So he had mentioned like this. So essentially it's the same thing. Yeah, that's the thing. So circle or the sphere or the circle and sphere. So the right angle triangle was something that we added just to make a diversion. Okay, this idea essentially how it developed was how people believed that the ideal geometric figure was circle was something because the heavenly bodies, all the planets are circle. So that's how they believed that okay, the ideal geometric figure was something that was circle, and there were thoughts that the that God was the best designer, the ideal designer. So essentially they developed that okay, this should be the ideal geometric figure. But essentially, the idea that there is an ideal geometric figure is something that is very debatable, because there can't be any ideal geometric figure. So the application has to be mentioned. Okay. So a continuation kind of question. The onset of our idealism, people believed. So essentially, they also believed, as he had said, that there was a belief on the number of the shape. They also believed on the number 10 being ideal. So because there must be 10 heavenly bodies. So they pre-assumed that there are 10 heavenly bodies. So they discovered Earth, Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn, and these are the two blanks that we have to fill. Pluto, Neptune. Okay, not yet. Maybe wholly. So one of the answers we have got, another one we have not. all the celestial heavenly bodies. So yeah, so yeah, the first one that you all are mentioning, it was the celestial hemisphere of stars. And then the counter earth. So there must be some another one which is essentially looked like the earth. They called it as a counter earth. So, and it is interesting because they have only told that it is a celestial hemisphere of stars, and the reason the counter earth and the counter earth. So it was something that it came as an interesting thing, because mostly they had called it a hemisphere because only it was observable from the north hemisphere of earth. So they were just saying that only there is a northern part, only from the north hemisphere the stars are visible, and the counter earth, it is not visible because it is not visible from the north hemisphere. So it must be hidden somewhere in the southern part of the earth. So that's how they couldn't see it, and essentially couldn't get the other heavenly bodies. So that's how they had.
Sir, I have a question.
Mhm.
Sir, like as per our general knowledge, we know that there are 9 planets. Okay, so
Mhm.
Pluto in this sequence is missing, and as per my knowledge, like to whatever extent I'm able to recollect, I don't think so. Uh, Sir has mentioned anything like about the Pythagoras, like the ideal circle, ideal figure, ideal geometric shape is circle, or even about this problem. So I'm not able to recollect whether Sir covered this. If Sir has not covered this and it is still coming into the syllabus, so what do you think should be the appropriate book for us to study for the exam?
So the appropriate book essentially is the one that has been prescribed. The name is the Research Methodology for Natural Sciences, written by Professor Soumitra. Essentially, that is the one that has to be followed, kind of, if you want to follow it. Yeah.
Otherwise, this is not covered, I guess, in the videos that Sir has taken.
Yeah, it is not covered.
I think it's covered. I mean,
No, sir, no.
in the initial, like maybe in episode like the one, and because I also have a faint memory that Sir was telling a kind of a story that they thought of
It is covered.
it is covered.
It
I
is
believe.
covered.
Like I have a strong feeling
This
that
might be covered, but I'm talking about the previous one, the ideal geometric shape, according to
Circle
Pythagoras.
is
yeah,
sir.
that
That
was a
is not
tricky
covered.
one. Yeah, that was a tricky one, but
That's not covered.
yeah. But
Is
the
it?
idealism of circle, that was covered. So on the basis of that, maybe that was a
I
trick
think,
question.
yeah, I think it was covered as per,
Okay, okay.
but
All
yeah.
right. Thank you, sir.
Okay. Yeah. So essentially, yeah, because these are something that is talking about the philosophy, something or the other is something that we are talking about, kind of a journey here. So some milestones maybe skipped somewhere, and so it is something. So it is something that depends on whatever. So there's a lot of milestones, we tend to forget some of it, and sometimes we can't recall, or otherwise sometimes it has not been covered or so in some source or something. So it happens, I think. So yeah,
One question can I ask?
please.
Sir, what is that? Do we need to refer the other books or this syllabus, whatever the syllabus, whatever the content that is taught in a video lecture? It is sufficient for information point of view.
Yeah, I think so, because
Because it itself is a vast, syllabus.
true.
Because when I took the about printout, so that comes to some 150 pages and like that. So
True.
it is very difficult to go through it and read and then memorize it. So
Yeah.
getting the time for preparation to manage what you
Yeah.
suggest?
I think so. I think so. Yeah. I think so. If going by the videos, and if any more help is needed, buying the same book of the same name as like the course book that is suggested is the best source. Because this course is something that is made on how the science has to be done, and how so the thing is it has a lot of so this the idealistic view, the view of the course can change a lot, and also there is a lot of topics. Essentially there can be a n number of topics, more n number of topics that are there that are essential for science.
Yeah, but then,
So
but now see that this video lectures they are based on this book which is written by Professor
yeah.
Sir, no?
Yeah, so essentially I think the contents are same, so you won't find any stark
Because
difference maybe.
we
One
won't
two
be able to get time because as I just said that it's a
yeah,
vast
fast topic,
video lecture.
truly
And see only a fourth week we have completed, okay, eight weeks to go,
yeah,
and a lot of materials to come. So I don't think
true
we,
true true true
at the end of this video lecture, we will be getting the time for
Yeah, but the thing is, the book I believe is same as that of the video. So I got the book from here, and then I checked it up. The contents was same actually. So it's up to you if you want to read it in a textual form. I think the book is.
But then it should not happen that whatever we are going to this video, then in the final exam something different will be asked.
Yeah.
Well,
So there can be some tricky stuff that can be asked. So that's kind of something that
don't
will.
have any problem with and all, but that should be based on whatever they taught in the video lecture. So
Yeah.
that should come from the video lecture. That is my
True, true, true.
And then there are
Yeah.
n number of books, and we don't know what to read and what to
Yeah.
what. So that will
Yeah.
become a big one
True.
because time is and
Yeah.
other exams also.
Got it. Yeah.
So please ensure at least there is
Yeah. The thing is, I am only basically my part is only till doing the problem discussions and discussing the problems with you, and also kind of learning through it. So I am also a PhD student, and the thing is I am also not involved with the essentially the final setting up of paper. So
it's fine. But the
yeah.
question is that the question should not be out of the syllabus. They should be based on this whatever they
Practically,
taught.
yeah. Practically, I
That
think,
is,
yeah. I do believe that being it an NPTEL course, such things will be kept in mind by the instructors.
yeah, because this syllabus is also this is on the merit
Yeah.
merit ground, so
Mhm.
it's not like that.
Yeah.
But then they should not ask
Yeah.
outside the syllabus.
Actually, I have also done a lot of courses. So in NPTEL, so yeah, it tends to be like we as a student do usually feel that sometimes it goes out of the thing and out of the scope. Maybe sometimes that's the way that people maybe test it or see how the people's perform. So
No, because
yeah.
we don't mind to refer the books, but actually to the time constraint and restrictions, actually we have no time. Because I think this is the time sufficient for
Got it.
this level. That's not enough.
Okay. Yeah, yeah, we will see it to it. Okay, maybe you can go to the next question.
Thank you, sir. Thank you.
So then we also had a Copernican idea of the solar system. So Copernicus, somebody that who was working during the Renaissance period, the 15th century period. Okay, can anybody tell what is epicyclic motion of planets?
Not in circular motion, it is an epicyclic, like it is elongated trajectory.
Yeah, the current idea of how planets move, like how we know that currently planets move not in a or not in a perfect circle, but it's
Hmm.
kind of an eclipse, and that is why these different seasons happen. Okay,
Is
so
it?
that idea, different seasons happen.
Okay.
Yeah.
Epicyclic and elliptical paths are the same.
Okay. Yeah, maybe I'm a bit confused in that.
Yeah. Yeah. Anybody has any thoughts on it? Like difference, what epicyclic motion of planet means?
Okay, yeah. As far as I remember the case, there is also one theory which states that the planets are also have a small kind of circle. Like there is a great ring around it, and the
Hmm.
planets are also moving in independent circles. So maybe that idea.
Okay. So as you mentioned the elliptical paths, can you tell who gave that idea?
Uh, I have I can't remember it like right now.
Huh?
Yeah,
Ptolemy.
Is it?
Ptolemy.
I have a strong belief that it was not Copernicus. Yeah, but who exactly gave that idea, I'm not like
Okay.
very sure.
It's Ptolemy.
Yeah, maybe Ptolemy. Yeah.
So yeah, the answer for this is Sun at the center and all other planets around it. So as we were discussing what epicyclic motion means, so essentially if it has a bigger circle, so planets will move in smaller circles also. So that is called as epicyclic motion. So another idea that you had told, that was elliptical paths. Planets move in elliptical path. So this is epicyclic, and this is this was the I don't know so basically elliptical path. So this idea was given by. So both of them are covered actually in the course. So yeah, Ptolemy, yeah, correct. So this was covered. This was given by Ptolemy. An elliptical path. Not precisely maybe. The Newton's thoughts may be very useful here, but not directly. So
But I'm
it is.
pretty sure that this idea was given like much later,
Yeah,
and
yeah,
science was more concrete and
yeah,
not based on
yeah.
philosophy.
So
Okay,
yeah,
so
it
that
was
I'm
it was
pretty
in the
sure.
also in the Renaissance period.
Yeah, exactly. Yes.
So this was with the three laws of planetary motion.
Kepler.
Yeah,
Kepler.
Kepler.
Yeah.
Kepler was very important. Uh, so he essentially gave uh, that goes with the elliptical path. So coincidentally, that also was covered in the thing. And so yeah, so okay, can go to the next question. So one question from the scientific Indian contributions.
Most probably.
C is the answer.
Okay. So here I think no discussion may be kind of a fact. So so this is so first is a statement in which tell that all mechanisms have a few characteristic features. First, they have that parts that fit together. Second, they require a motive force to set them going. And third, the parts interact. Which of group of scientists believe in such thoughts? So we discussed subjective, we discussed idealist, we discussed objective, we discussed relative,
Mechanical
mechanical.
materialist.
Okay.
Mechanical
So,
materialist.
so mechanical metal is something that is not. So can anybody tell what is mechanical school of thinking?
So it's an idea which suggests that every matter in this world is basically, let's say, is a part of a huge design, which is designed like just like a machine. Okay, so every part has its own role to play, and overall they are moving this machine, like moving this machine.
Anybody would like to add in?
The main idea of the mechanical material was that the world is sort of composed of matter, and the whole picture was like a machine. The world was viewed like a machine, and each individual things are viewed as a part of the machine. That is what the idea.
So here so can you fit the idea with the statement that is written?
And one more thing is that there is also a driving force which is like moving that machine. Okay, like initially someone gave that push, and eventually like that force that is acting, that's how things are working. Okay, so there was also a question that if it's a machine, then who gives the first push to the matter or the machine to move? So that was one idea which I was doing like.
That the world is nothing but a big machine, genetic machine, and all we are the living human. They are the parts of different parts of the machine.
Okay. So we got that firstly they have parts that fit together. Second, they require motive force to set them, and the third is a part interact. So what does it mean?
Sorry?
Like the first and the second. So first they have parts that fit together, and second they require motive force. So this is something that we all are discussing what that basically tells. And the third part, the parts interact. What does it essentially mean? Like
Maybe one part affecting, like one matter affecting other. I'm just guessing it.
okay.
The particle of the work is that
Directions of these parts that it means it is very different. They all are moving. They are not fixed.
And
That's why they are.
how they are moving? So what basically tells them how to behave or how to move?
There is a force behind it.
Yeah. So there are some
Law.
fixed laws. So essentially, then it comes to the fixed laws that we were discussing. So during this time, there was basically development of the different laws. So they told that these parts interacted to each other using some fixed laws. So
That
essentially,
was the law of identity and the limitations law that.
uh, no, I am talking about some so essentially, if we're talking about some kind of planetary motions, then we have the different equations of not only planetary maybe at that time, okay, but maybe so how two balls interacted. We could how the projectiles were done. So we can
Okay.
essentially the fixed laws, the laws of Newton that was essentially prevalent at that time. Okay, so essentially here the idea is the mechanical materialist, as everybody told. Okay, maybe before this, where does the idea of this mechanical materialism fail?
Yeah, as I mentioned that the question that who made the first push.
Mm-hmm.
Okay, so that is where the the mechanical materials don't have a concrete answer, because eventually they end up explaining that there is a superhuman, or uh, something, someone outside the world who has made the first push. So
Mm-hmm.
eventually, while explaining that who made the first push, they actually like prove that there is something which we don't know and we don't interact who has made the first push. So that only was the drawback in this idea phase.
Okay.
They believe that it might be a force by the god. Okay, God was
Yeah.
behind it, the
Mm.
first force. But then later it was proved that it was a gravitational force.
Okay. Any other difference or any other defect? No. Uh, so actually, if so, the one of the important parts of this law was the idea of fixed laws. So essentially, everything should be governed by this fixed laws. Okay. Okay. Maybe. Okay, somewhere. Okay, Abhishek, maybe we can take that once we discuss this completely. Uh, so one of the important thing was fixed laws. So essentially, it has said that each parts interacted in the same way, and it would go on interacting with the same way. So that's the thing. So essentially, there was no place for evolution or any change. So that's how this idea essentially failed, because we see that, like in the case of natural selection, and so there is no such fixed laws there how it should go on, because if there is some fixed law, then there will be no mutation, no change. That's how that these mechanical materialistic thoughts didn't get any space for this small changes or such things. So essentially, that's why they couldn't accommodate the whole of the things. Now coming to Abhishek question, mechanical materialism. The characteristic features of mechanical materialism are the belief that matter does not exist independent of our consciousness, viewing the world as law governed, requiring no divine intervention, viewing the world as a gigantic machine, the belief that science will be built based on personal realization. Which one is correct? Okay, anybody would like to answer? You can also think upon that. So the question is visible, yeah. Abhishek has written down in the chat box. So
Is it a multiple choice question or a single answer?
maybe Abhishek can answer that.
Okay.
Multiple choice. Assignment 4 question it is. Okay. So actually we should not discuss the assignment questions. But okay, I think the date has anyway gone, I think. So I think it's okay. Yeah, I believe so. Last year is 22.
Yeah,
But
it's
then,
not gone actually.
then I think we should not discuss actually. So okay, maybe we shouldn't discuss. Yeah, that's something that was given by as a rule from NPTEL. Uh, yeah, Abhishek, I think it's okay for that. Yeah. Okay, we go to the next thing maybe.
I think second and third. Second and third.
Okay, then we can maybe because this it has the date has not been come. Maybe that's how we don't discuss it maybe in the problem solving sessions. So direct questions can't be asked. Any conceptual things maybe accommodate.
That should not discuss.
Yeah, true. So yeah, sorry. Okay.
Wanted to get the answer.
Yeah, so, yeah. No issue. Yeah, it worked, but yeah,
Otherwise, everybody will ask the questions.
true.
Get the
It's
answer cleared.
yeah. Okay. No issue. Maybe Abhishek, once you answer it, maybe we can discuss in the next session anytime. Yeah. So the next question is, what is the main difference between materialism and positivism schools of thinking? So there is a thin difference that is possible, that is there, and so we have learned about materialism. Positivism was something that we haven't discussed truly. So can anybody explain what positivism is?
Matter does not exist unless you observe.
Okay.
Everything exists unless you no observation, there is no inner being.
Mhm. So what would be the difference?
Materialism, because there was subjective materialism, then existence of matter does not exist as a consciousness. If you not see like
Mhm.
microorganism,
But
but
if
it
you
is
are
outside.
including subjective, then it changes the thing maybe. Yeah. Yeah. It's like truly materialism and positivism. If you add subjective or objective, that is kind of a different thing altogether.
So is there any option for this question, or we are
Uh,
expected to answer it in the paragraph?
yeah, so the difference essentially can be kind of summarized in a one line, but yeah, anything out for a discussion kind of.
In materialism, matter can exist independent of our consciousness, but in positivism, it says that whatever we observe, it is
Mm.
true. So, But independent of our consciousness means like microorganisms can exist, so that is materialism. But in positivism, it is not included.
Okay, but after that, so the idea of positivism was there during the 18th century, in the 19th century. So at that time, we had the microscopes. So essentially, we could see the microorganisms. So is it in materialism or positivism, or both maybe? Anybody?
Uh,
Yeah, please.
I'm just guessing the answer here.
Yeah, sure.
So, so I think the difference could be like in materialism, like in positive school of maybe even though you can't see that matter, but you
Mhm.
strongly believe that it exists, and
Okay.
it's just a step away.
Mhm.
Like it's kind of your inability, we can say, or your limitation that you can't have a device to detect that. But we
Okay.
strongly believe that it exists in positive school of thinking.
Okay.
Like that is my guess.
So, like, what is the difference?
So for example, when we say like take example of neutrinos, yes, the
Mhm.
neutrinos are so like so minute that
Mhm.
it's not even detectable yet. But
Okay.
scientists do believe in a theory that there are some particles such as neutrinos, and one day we will be having such kind of technology that
Mhm.
we can detect neutrinos. So this is the example I'm giving.
So this belief is from materialistic school of thought or positivistic school of thought, that we will be able to detect it in a future, kind of like near future.
Positive school of thinking.
Anybody would like to add anything?
The materialism is a theory
Mm.
uh, about what exists.
Okay.
Positivism only say things about knowledge, what we can know, and also very similar.
Maybe can you explain from an example, maybe? So the neutrinos example that you gave was kind of very close, and so yeah, that was kind of a close thing. But yeah, I think we need some modifications, and that guess was quite close. Maybe.
Television, we can study variance of sense or binary.
No, actually, there is a quite a small difference. So the difference is very small actually. So it's kind of a thin line. And this the things this positivism skill of thinking was something that was very crucial for some important Nobel prizes, what was given to Van der Waals. So if somebody is from chemical background, they will be, or maybe sciences background, will know how the importance of van der Waals forces are. So he got the Nobel Prize in 1910. And then we have Boltzmann uh, gas kinetic theory. I think if I believe what it is called. I am not a physicist though, but yeah. So he couldn't get the I think the Nobel, I believe, because he died. Actually, he did he perform like he did suicide, essentially committed suicide, and but the thing was positivism was one important thing that actually triggered this thing. So, and they don't give Nobel prizes in science to somebody who has already died. But I'm not sure actually if they got or not.
So can we say here in materialism it is a theory related to
Hmm.
mind, mind concept.
So
And
that is maybe idealism actually.
it is related or about physics as per your
So I think you are talking about ideas. So ideas will go to idealism. Uh,
knowledge.
so
I want to say positivism
mm,
is a is about knowledge. What we can know, we can sense it by learning, by
okay.
understanding.
Mhm.
It is related to physics. I want to say.
Yeah, it is
Posit-
essentially, yeah, it is it has relations
Materialism
to
is
physics.
related to mind or
Okay.
concept of what exists.
Okay, okay. Yeah, like it is related, like the point it you have made, it is related to physics. I think that is kind of the closest one, but yeah. Uh,
I'm just trying to say so.
yeah, yeah, true, true, true. No issue, no issue. So, the thought positivism that one of you told that they used to treat anything that is they won't treat anything as real unless it is observable. So so as you told the example of neutrinos, so they so if it was positivistic thought, uh, they won't take it, but in a materialistic world they will take it as a thing. So positivism, though, you actually had reversed it. So the thing is, so it was a reverse explanation actually that you had given. You were taking materialism as the one that we will be. So the thought essentially that the neutrinos will be detected in the future, and so that's why we should believe neutrinos are there. It was a materialistic thought. While a positivistic thought is the neutrinos doesn't exist because we haven't been able to uh, essentially detect it or see it or feel it or what.
So Van der Waal was like in favor of positive school of thinking or materialism, because Van der Waal, as far as I remember,
Mm.
it's like a force between
Mm.
two atoms, right?
Yeah. So
So
essentially, he was on favor of what school. Essentially, that would be tough. Actually, I don't know what he was thinking, but yeah, because the thing is, there was a lot of discussions in a way. Actually, the field of chemistry, yeah, the field of chemistry essentially discusses a lot about interactions of molecules and how these molecules behave, how the electrons share, and the existence of atoms, existence of molecules. So the thing is, when we are talking about the Van der Waals thing, so there it was essentially, if I'm not like completely, I don't know, I am not kind of expert, but it essentially is that the forces behind the different molecules. Yeah. So if essentially then the positivistic people will be thinking that we can't see these molecules, we can't see this atom, we can't see at the atomic level. So how should we essentially tell there are some forces that come between them? So so the thing is, if there is no, if molecules don't exist only, so there is no question of forces, yeah, between these molecules. So that was kind of a thought, that was a positivism kind of thought, yeah.
But sir, if you take the example of coal, then you observe, but
Hmm. But how do you feel molecules?
that's what I'm saying. The coal will don't.
Yeah. So essentially we
Doing the
can't. Yeah.
so how can we explain whether it is so
Yeah.
how positivism school of thought they will explain this? Well, there are so
Yeah.
many things. I remember
Yeah.
going
So
to that side.
so that's why they call positivism as rise and fall of positivism. So sometimes
That's
rise and fall of positivism, people will tell it like this. So you can get some articles that essentially tells us about that. So uh, so yeah, I was talking about Boltzmann. Yeah, I think Boltzmann was an important person. So he gave a lot of things. One of the important thing was the kinetic theory. So and also the Boltzmann distribution, which is also an important part of it. Boltzmann distribution that we talk about in probability theory, I think. So uh, so essentially, yeah. So if we talk about them, and then I discuss that how Boltzmann committed suicide. So you can see that how, and that suicide was essentially triggered by his rejection of his work. So we can see that how people were at that time, how they believed their science, and how they got so engrossed in science that they were like they took such kind of steps. Though such things are not essentially, it's not the
And
end of the
another
world.
example is that
Yeah.
the example I can quote that there is a conversion of the energy that is from electrical to
True.
mechanical and like that.
True,
We
true.
cannot see that.
True,
That
true. Yeah, true.
then they get the results. That the vehicle is
Mhm.
moving. That
Yeah, essentially they actually thought that something was being transferred, some matter was transferred, and then it got given. Okay, there is something called as energy. That because there was no thought of laws of thermodynamics. So upon discovery of laws of thermodynamics, only such kind of things were possible. Yeah, that's what was also there. Nice example. And then there was Maxwell also. So Maxwell also at that time was also working on this theoretical validations of the molecular uh, I forgot the Maxwell's equations. Yeah, yeah, that they were also giving this theoretical idea of what I think Faraday had given. Faraday had given all these things. So one of the important person was Einstein. Actually, Einstein had actually cleared the confusion that
E is equal to
that there is an existence of molecules, and so he was kind of a materialist, to be told, and he told that yeah, these molecules and atom exist, and it doesn't depend on our consciousness and our ability to observe them. So it's like if they exist, and if our theories, so whatever theory they are they are telling about them is correct, so we can deduce some manifestations, so we can deduce some hypothesis, and those hypotheses can be tested. So that's what was told by Einstein. Essentially Einstein was one of the important told. But yeah, Einstein got Nobel. Yeah, Einstein got Nobel for what?
Theory of relativity.
Mhm. So so this question is not from maybe from the syllabus, but yeah.
got it.
And not from theory of relativity.
He got Nobel Prize on photoelectric effect.
Nice, yeah, photoelectric effect. So photoelectric effect, he got the Nobel Prize. So yeah, so he also talked about this molecular dimensions and those things. So yeah, that's how. And he also performed. I forgot the experiments, but yeah, some of the experiments also were performed by Einstein that essentially told that yeah, these molecules essentially are possible, are exist. And I have some examples though. But yeah, though actually if it's a mixed crowd, essentially we don't discuss. I can't totally discuss. So there were some examples on Brownian motion and diffusion of molecules. So he did this thing. So there is the concept of diffusion of molecules, how it depended on the time. So those are the things. I think the people from chemical engineering or chemistry can understand those things properly. But yeah, those things were developing essentially, and then Van der Waals got the Nobel Prize in 1910. and and yeah, then in at that period, on that period of 19 like after 1908 or some to 1915 maybe, there was a huge kind of papers on this atomic and molecular things. So that was, so these are the kind of revolutionary science that we were discussing in the first set. Yeah, there is something called as revolutionary science. So that revolutions are essentially needed, and that essentially changes the way that science has been followed. Okay, maybe we have taken this where did mechanical. So yeah, we discussed essentially this idea. So that time I didn't maybe not formally told the answer, but yeah, it could not explain the nature of development, the emergence of new qualities. Can anybody tell what is emergence of new qualities?
Yeah, the theory of the theory of evolution basically.
Okay.
How if you are saying that there is a law which has to be followed that by that machine,
Hmm.
then why things are why you observe the changes happening in physics.
Yeah, it's also like how
I think
how hmm.
Darwin
Means,
basically like kind of disprove that
hmm.
it's not like they are not abided by some laws. They are
Actually,
actually like they are making their own laws or
hmm.
own nature or own qualities depending on the survival and the nature.
True. Yeah, yeah, yeah. It's like yeah, everything is not a machine. Yeah, like we develop how we are born and we grow up and how the things. So it's not in the same pace. Yeah, how we grow up and then the things essentially we don't grow up after some time of period. Then something other. So the basically the development in other ways it develops, maybe in the mental, physical, in some other way. So essentially there are so it's not like we will grow on and on. So there are no such laws like it fixes everything. Maybe in some selective parts such laws can be made depending on the conditions essentially that we talked. So there should be some conditions essentially, and such selective conditions only derives this. So we have to tell basically that okay, like the universal law of gravitation. Yeah, essentially it also fails in some conditions. It can't also tell what would be the motion of a planet, heavenly planet, or such things, or a particle as close to an electron moving at the speed of light. So essentially such, then they have relativistic theory and all these things. So yeah, there is nothing called universal. So science also needs such developments, and also needs selective things that essentially tells the emergence of new qualities, like we growing up, the plant growing up from a seed. So yeah, everything is not kind of ruled by a fixed law. That's what it is. So yeah, so William Paley was argued that there is evolution in the biological world. Each organism has productive, intelligent design. The Earth rotates around its axis, and the Earth is flat.
Each organism is a product of intelligent design.
Okay. So this is kind of what kind of thought, like you think so?
Yeah, it's mechanical materialism kind of thought, but with an additional thought that there is a supreme power which has designed, and according to him, like the designer, everything is right. Okay, so basically he was completely opposite of the theory of evolution, right?
Yeah, yeah, it was actually this kind. Yeah, the correct answer is Richard. So such kind of thoughts essentially like stopped actually the laws that were coming for. So a lot of people were just taking okay such this the thing of speciation and how the species generated from each other. They rejected those ideas. They told that okay, this a single species has come on existence just like as a private, like a separate entity. There was no scope for each any other species essentially contributing in its development or evolution maybe. Yeah, so that's the thing. So Paley was a arguer on those. So actually it was not totally mechanical materialism, but I think at that time the materialism idea of materialism or mechanical thought actually didn't come. So mostly it was kind of idealistic kind of thought, because yeah, the mechanical thought was something that Newton had essentially given at that time. So that was something that maybe maybe
Actually,
mature materialism. Yeah.
actually, like everything which is related to biology, ultimately they were very much reluctant to adapt this idea of materialism, because at the end they somehow base their idea on the basis of some kind of idealism. Okay, because
Yeah.
they will agree that yeah, there is a kind of a rule or a kind of a law which is happening, or maybe things matters are related to each other, but ultimately they believe that there is a supreme entity which is running all these rules. Okay, so before Darwin, they were like, in a not in a very strong way, but definitely in a way they were idealistic.
Yeah, true. So
They
yeah,
were
this
the biology was like the field of biology was struggling a lot to adapt this idea of materialism, and
yeah, true,
like
true.
unlike physics and chemical, yeah,
Mm.
biology was struggling a lot, and
Yeah,
even in a
totally,
later
totally,
period, yeah.
totally agree. Yeah, totally agree. Yeah. Nice statement. Yeah. So problem 11 was something that we didn't discuss in the last class. So yeah, we have some time, then we can discuss this. So last time actually we also got exhausted with the time, so but I didn't took it up. Huh? one actually. Anyway, we have time, so we can give a thought actually. It's a single correct if I think so, if I remember. Okay, maybe one of you can start explaining how are you doing the things. Am I audible? Okay.
Sir, can I explain? Means
Yeah, please.
what I think, maybe I may be wrong.
No issue.
The fourth one, in the third statement, it is saying that we have to take n plus one dog and make a group of n dogs with similar color and leave just one. Means it may be of the same color or it may be of the different color, right? And in the fourth, it is saying that you include that left dog and it must be of the same color. So I think third and fourth means contradict.
I don't know. It tells. So the third point is so essentially it has n plus one dogs. So you take a collection of n dog,
And
So one dog is left,
right.
and so it sees inference that all of them must be of the same color as per our assumption. So we are trying to prove that all dogs in a group are the same color. So
Means
each
n plus 1 are having the same color, or n is having the same color?
no
That
n because we have left the one.
1, 1, right.
Yeah.
Huh. Now take a different group to the left of increment dog in the group must also. I think there is a logical error in step 4, I think.
Okay, what's the
Maybe what others are thinking.
So can I explain one thing?
please?
Yeah,
Please.
according to the step 4, they have said that it is n plus 1 dog. And
Mm.
now if we are taking only n dogs, leaving this one behind. Okay, so that one dog is alone and there is a group of only n dogs, right? And the step 4 is saying that
Please,
now we are creating a group.
actually, I'm not able to, just maybe a little slow. Actually, I can't follow. The voice is not totally like clear. Can you speak little slowly?
Am I audible now?
Yeah, you can. You are audible. Little bit slowly. Maybe that's so everybody can follow it then.
Okay. So, sir, step 3 is saying that out of n plus 1 dog, we have to create, means a group is created using n dogs and all of them are having same color. Okay. And now step 4 is saying that we have to take a different group with the left out dog included. So there is, in the step 4, they are making another group. In that group, only one dog is there according to statement 1. Take a group with single dog, and this statement is trivially true.
Okay.
Now here it says that statement 4, second part, every dog in this group must be the same color according to our assumption.
Okay.
So according to me, like, this could be a small logical error that a group could contain more than one. Okay, but according to statement 1, it is saying that even if there is one single dog is there in that group, it is considered to be a group, right? And every dog, so here there is no question which arises about every dog, because there is only one particular dog, and if that dog is taken from n plus 1 subset main group, then we should be also having the same color. So I feel that there is some kind of logical error while constructing the statement, which is not leading to the final objective. So I feel that there is a logical error.
Anybody else would like to add anything?
What I see here, I personally feel that the step 2 and 4 are actually not contradicting but supportive of the logic, because see, in the second step you are actually making an assumption that this thing which you have observed, that take a group with a single dog, and if it's of the same color, then it's trivially true, and we are making an assumption in the second one. Okay, and in the fourth one, if you carefully observe, they are saying
No, the first one is a given. So we have a single dog. Yeah. Please.
I was saying that we are making an assumption in the second step, and in the fourth step we are saying that if our assumption is true, like whatever the assumption we have made in the second step, if it's true, then every dog in this group has to be in the same color, including the one which we have left out. Okay. So in that way, I don't see a logical error here. In fact, it is like a more firm logic, because you are intentionally leaving one dog out. So basically we are giving a chance of of a chance of a, what I can say is a negation. Okay, so you
Okay.
are basically leaving one out with a, you are basically giving a chance to the randomness to happen on that particular dog. Okay, but in the next step you are checking that that randomness is not happening. Okay, so I think there is a more concrete idea of logic here. Like according to me, I may be wrong, but that's how I am looking at this whole experiment.
Okay.
And I do support that in step 5 we do like try to hide that assumption that there could be overlapping within the group. Okay.
How?
So because in with the dog which we have left out, in the next step we have included into the group.
Mm-hmm.
Okay. So in that way, if we are saying that the same ideology is true for n equal to 2, then eventually there will be there will be a overlapping in the groups which we have formed.
Okay.
So yeah. So according to me, either the answer is in step 5 we are hiding an assumption, or there is no logical error. I don't see a logical error at least till step 4, according to me.
Okay.
Even in step 5 I don't see a logical error, but yeah, I see that we are hiding an assumption. So I don't think that there is any logical error, but we are hiding an assumption. That is my final verdict on this problem, like, according to me. Yeah.
Okay. Nice. Anybody else?
Maybe you should break the suspense now.
Yeah. So the thing you told, yeah, on the step 5 we have a hidden assumption. So for n equal to 2, essentially the two groups overlap, and essentially that's why. So it's a hidden assumption. So if we are essentially, if it would be logically correct if we would have told the assumption also, but essentially if we are hiding the assumption, so that's what is also something that essentially flaws the logic. So the correct answer would be that essentially it hides logic, and there's two groups over here. So this is one of the classical problems. So essentially it tells. So this problem is actually you can search it. It's a kind of a famous program. The title of the problem is. I lost my pen. It tells is all horses are the same color. So this is one of the classical problem, and so I just changed horses to dogs. Maybe that's the creativity I added. So yeah. So this is one of the classical problem, and so we can maybe search it, and there are a lot of videos that will essentially tell how this logic has been done, and that's a nice visually they will tell that how things have been. So kind of a classical example. So yeah, that's all for today. And any questions over it? So so. Yeah, so any questions pertaining to hello? Yeah. Okay, if there is no such questions, we can close the meeting. I will be staying for 5 minutes or so, and others are free to leave.
Excuse me, sir. Can you please
Please.
explain what is inductive logic?
Inductive logic. Okay. So. Okay. So maybe I can pull up the uh, last thing that we had made. I think week 2. Yeah. Inductive logic was in November. Okay. So inductive logic. So it's basically the type of reasoning that involves making general conclusions based on specific observations or evidence. So it can be like the sun rises at east, in the east, from the east maybe. Yeah. So that's kind of a general conclusion. Yeah, you have seen it. From your childhood you have seen that it has always been rising from east, not ever from west. So it's like of a general conclusion, but someday it can, maybe in some time it can, but we don't know in the near future if it can maybe rise on the west also. So it's just like what we derive from the general conclusion. It's like we go for we when we see the clouds, black dark clouds, we know that okay, it's going to rain, or such kind of things. So it's like that. Okay, I think somebody is. Yeah. And so a conclusion is drawn based on evidence or observations, and the conclusion is considered probably or likely but not necessarily certain. So we are not certain actually about the observation. It just that it is a general conclusion, a general observation. So it's like, for example, if a person observes that all apples that they have eaten from a certain tree are sweet, so they might conclude that all the apples from that tree are sweet. But this conclusion is only based on evidence. Yeah, there may be some. So basically, because we have only eaten sweet apples, like coincidentally, those were sweet apples, and but that not maybe certain. Okay, the conclusion might change. Like if you encounter a apple that from the same tree that was sour. So it's kind of inductive logic. We already know that okay, from this. Tree we have only sweet apples. So and also we discussed about something called as probabilistic inductive reasoning and also deterministic inductive reasoning, so in which we essentially also so basically to be free from the logical error, we essentially add a probabilistic factor. So it's like more likely or highly likely that this thing is so we can say that it is highly likely that the apple you take from this tree will be sweet. Okay, so that's based on the probabilistic factor, like because of the probability, like how you calculate how does we calculate our probability for every event. Yeah, we calculate an event and then we attach the probabilistic factor along it. The 60% of the apple will be sweet from this, 70-80% of this will be sweet. Then we have deterministic. It's like deterministic means that till the time we haven't encountered So it's like we haven't encountered a sour apple for now, but if it we have encountered it, so till that time this conclusion is correct. So that is deterministic inductive reasoning. So these are the two kinds of inductive logic that is possible. I hope I made sense here.
But in the inductive logic, we go from a specific to general. Hello.
Please, yeah.
In this we go from a specific to general. Am I right?
Yeah. So it's
So
from
then,
specific to logic. Yeah, specific. So each time a person eats an apple, the specific event, and then we get okay. This is a general truth, kind of. That's the specific to kind of general
Could you
that we
please,
go.
could you please explain again?
So it's like the each apple. So each time a person eats an apple, it's a specific event. So that is
Yeah.
sweet or not sweet. But then he gets okay, it's sweet. So that's a specific. Okay. So after a lot of time, they get okay. Generally, they say that okay, this tree only has sweet apples. So we go from a specific event to a general event.
Yeah. Thank you.
Yeah.
Yeah, if we have a few more minutes, can I ask one? Like, since
Sure,
we are
sure.
discussing inductive and deductive logic here.
Sure.
Yeah, I think in assignment 2, I guess, there was an answer. Like the correct answer was it was a combination of deductive and inductive logic. And
yeah.
it actually kind of baffles my mind because by that time I was thinking that there could only be two approaches, either
Two
it could be
approaches.
inductive or deductive. I never
Yeah.
thought of having a combination. So I still have that doubt, or maybe you can clear it with a concrete example
Truly.
where a combination is used.
Actually, the thing is, I am also, truly speaking, honestly, I am also doubtful in that. I also believe there should be actually one logic behind it. But yeah, actually, I am not also that theoretically strong.
I
But
actually I actually also gave it a thought, assuming that such kind of thing happened.
maybe
And one
the best
possible,
thing, yeah, sure. The thing is,
one,
if we know the answer, making a logic out of it, like how the answer has come, it's
okay,
easy. But the thing is now, because we now know the answer, yeah, that's
yeah,
the
that
thing is,
yes.
yeah.
So if I am if we are assuming that the answer is correct here, so there is one possible scenario that I can came up with where
Please.
the both logics are applied. Like I don't know, I am not an expert like this.
True.
Probably you have worked more with these types of questions, but there is one
Not-
scenario where
Okay.
just imagine that you thought of a theory which is true, and then you are trying to prove it on some kind of subject. So that is
Okay.
kind of deduction, okay, deductive logic. But
But
during the
that is normal hypothesis testing, yeah.
okay.
Uh,
I don't know. Like, I was thinking of a scenario where let's say that logic which you are trying to prove on these subjects that came out to be not true. And now when
Okay.
you are in a search that why it is not true, you came up with another theory which explains that why it is not true. So in a sense, you first started with a deductive idea, and then in search of explanation that why it didn't happen, you are proposing another theory. So maybe I don't know. I was just
Yeah, I
giving it
also
a thought.
I also forgot the question actually. I don't know what was the particular question?
It's either in assignment 2, but
Yeah.
I'm still confused about it.
Uh,
Maybe if you can forward this question
maybe
to
the
professor.
well,
Yeah.
maybe the one thing is we can ask it in the problem forum. So
Okay.
essentially there I think professor will take it directly. This was the problem, I think.
Yeah, I think this was.
Yeah, started. So yeah, so one thing is we can ask it in the ask it in the forum, then I think it will be. So it's yeah. So truly speaking, honestly, I am also kind of not maybe convinced or not maybe not seeing the theoretical view of it. So yeah, I also like I can't also maybe because we know the answer. Yeah, it changes the truth. But yeah,
Yeah.
yeah. But
Okay.
typically speaking, I also don't know.
Anyway, thank you
Yeah,
for your
not
time.
sure. Yeah, sure,
Yeah.
sure.
So thank you.
Thank you. Yeah, thanks a lot for joining, and looking forward to the next sessions. If any feedback you have, kindly leave it, and I will work upon it. And that's how we maybe learn. Yeah. Okay. Okay. As I had repeated that people are free to leave, and if you have any feedback or any questions, you can leave it in the chat. And thanks a lot.
Yeah, just one request. Please
Sure.
upload the videos as soon as possible.
Yeah, I think so. Personally, I upload it the day of. It does take a lot, like time, like kind of that
Okay.
YouTube takes. But essentially, I do it in the same day. I
Okay.
can't tell for the other TS maybe, but yeah, I do it time.
Yes. Okay.
Okay.
Speaking of the feedback, I think like among all the TAs, I really enjoyed your session because it actually goes in a flow.
Thanks.
So
Thanks.
that actually really helps to get the understanding.
Okay. Okay.
So you really are doing a great job. Yeah.
Thanks. 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 Yeah.
So thank you very much. Bye bye.
Yeah. Sure. Sure.
Thank you, sir.
Thank you. Thank you. Thank you all.